Welcome to the PS2 Learning Set 2, Why Do Some Things Stop? Review for lessons 5 through 7. So I label this as success criteria because these are the things you're going to have to know. It's not necessarily individual items, but it's the broad concept. How do things work overall? And before we get started on that, I just want you to take a look at this, and this is at the top of your review sheet. Be sure to review your formative assessments. You've already taken 2 tests in class, so you know a lot of the test questions come from the quizzes. We're not trying to trick you. We're not trying to fool you. We're upfront and honest with you. We tell you exactly what you need to know. Make sure that you also read the assigned readings. Again, you've taken several tests, so you know that a lot of the questions, not a lot of the questions, but several of the test questions come from the readings. And that's why it's so important to annotate. If you can figure out what the main ideas are, and we've gone through most of the readings, but if you can highlight the main ideas, if you can underline them, when it comes to the test and you can use your books on a test, you may not remember everything, but you can go to the reading, and if you have all the main points underlined, the odds are that's one of the test questions. Now, many of the test questions come from the labs and activities. So again, if you've been absent, if you're not completing stuff in class, make sure you complete things. That way you'll be able to have those for the test. And when we go through activities in class, if you get stuff wrong, maybe cross a line through it and add what you know to be correct or what we go over in class. And be sure to review the scientific principles. They're up there on the wall. They're going to stay on the wall for the test. Use them if you need them. So the first item deals with thermal energy. And when we talk about thermal energy, know that thermal energy is what it is and how one determines the amount of thermal energy. Now, when we talk about thermal energy, we really have to take a look at mass and temperature. If temperature stays the same, if something has more mass, it's got more thermal energy. If it's got less mass, it's got less thermal energy. However, if the mass stays the same, whichever one has more temperature has more thermal energy. So sometimes we're going to get into some conundrums where you don't really know for sure what's what. And we'll go through one of these in a review. So when we talk about thermal energy, remember, thermal energy, TE, is an average of the total kinetic energy in an object. It's how fast all those molecules are moving. It's an average of how fast they're moving. So temperature is a measure of the average heat or thermal energy of the molecules in a substance. So here we go. This is what's written on your paper. Be able to compare 2 objects to determine which object has more thermal energy. Be able to explain why one has more thermal energy than the other. So here's an example. Which one has more thermal energy? Explain why. So if you had a large glass of water or a small glass. Now right there you can't tell, but read on. Water is the same temperature. Okay. So remember, mass and temperature. Temperature is the same. It says it right here. So we know that the temperature is the same. What else do we know? We know that we have a large glass of water, and then we have a small glass of water. So temperature doesn't matter because it's the same. So if we have a larger glass of water, is it going to have more mass than a small glass? Yep. So which one's going to have more? The large glass of water is going to have more thermal energy. Why? Because there's more mass and the temperature is the same. Now look at this one. If we have a 500 milliliter beaker of cold water and we've got a 5 milliliter beaker of hot water, what do you think for this one? Now this one's a little tricky. So we have a lot more here. So it's got a lot larger mass, but it's cold water. Here there's a much smaller amount, but it's hot water. So if you get into a situation like this, your answer might be something to the effect of, we need more information. How hot is the water? How cold is the water? We cannot tell because we don't know for sure what's what as far as how hot it is, how cold it is. Yes, there's more here, but yet it's hotter here. So when one goes up, the other one goes down. We don't know for sure which one has more thermal energy. Be able to identify where thermal energy comes from. So for example, here it says an ice cube melts in my hand. So if we have an ice cube, and sorry for the drawing, but like here's my hand, I'm holding on to it. and the water, it looks more like a finger, but the water is melting. Where did that thermal energy come from? Well, some of it would have come from my hand. So some of the thermal energy is coming from my hand if I'm holding it. Where else? You might say, oh, some of it's coming from the air as well. Now, if I have it in a firm grip and I'm squeezing it and my hand's completely around it, of course it's just going to come from my hand. But if I'm just holding it in my hand, like in the palm of my hand, and it starts to melt, well, again, some of the thermal energy comes from my hand, some comes from the air. So you're going to get a scenario, and you're going to have to be able to explain where did the thermal energy come from it. So a lot of times it's going to come from things that it's in contact with. What is this ice cube in contact with? It's in contact with the hand. It's in contact with the air. So that does conclude your notes for the first one on your success criteria review sheet. Thanks.